we want to take a look at the concept of inequalities. And in order to understand inequalities, we first have to understand inequality symbols. The first one, of course, is greater than. Secondly, less than, greater than or equal to, less than or equal to. These are four popular symbols that we're used to when we discuss the concept of inequalities. So we want to look at inequalities in three ways. We're going to look at being able to solve inequalities, being able to graph inequalities, and being able to take a word problem and write an inequality and or solve it from a word problem. So first, let's look at the first concept, which is to simply be able to solve inequalities. Actually, we can put solving and graphing together. So let's put them together. Let's be able to solve and graph, and we'll talk about what graphing and inequality is all about. So here's our first problem. Let's say we have x plus 1 is greater than 0. X plus 1 is greater than 0. Now, just like we've said before in class, I like the split because I think the split helps you guys understand things a little bit better. What I mean by the split is let's split this inequality in half according to the inequality symbol. So this is one side of the inequality, this is the other side of the inequality. And just like with solving equations, what we do to one side, we're going to do to the other side. So if we look at this and it says x plus 1, then we already know we're going to subtract 1 from both sides. The ones, of course, are going to cancel out. We'll have x left on this side. 0 minus 1 gives us a negative 1 on this side. And remember, our inequality symbol said greater than. So we're going to keep that inequality symbol here. And so our answer says x is greater than negative 1. Now remember I said we want to solve and graph. And I'm going to hope that you understand that when we say graph in inequalities, we graph them on a number line. So here's my number line. Number lines are split in the middle by 0. On the right hand side are all your positive values. And we're just going to put 2 of them on here. On your left hand side are your negative values. So we have, of course, negative 1 and negative 2. Now, according to this, it says x is greater than negative 2. What does that really mean when we talk about inequalities? That means that this number for x can be any value as long as that value is greater than negative 1. So negative 1 can't be included in our solution, but any value that is greater than negative 1 can. So when we're graphing x is greater than negative 1, we put an open circle on negative 1. And we put an open circle to indicate that negative 1 is not a part of our answer. And if we're going greater than, we know that we want to shade our line to the right, because any values that are greater than negative 1 would be a solution. Let's try another inequality. Let's say we have the inequality 3x minus 7 is less than, or equal to 2x plus 1. So let's let that be our inequality this time. Just like last time, I like to split my inequality symbol right down the middle. And all it does is let me know that this is one side of the inequality. This is the other side. What I do to one side, I have to do to the other side. So this is just like equations. I would subtract 2x from both sides. And of course, x's can always go with x's. That makes it cancel here. 3x minus 2x gives me x minus 7 left on this side. Over here, all we have is 1. Still not finished. We can add 7 to both sides. And again, y'all know me. I like to have all my x's on the left, which is why I moved the x over and then moved the number over to the other side, because that way I have all my x's on the left. That's just how I like to do it, not saying that you have to do it that way. So now on this side, we're left with x. On this side, we're left with an 8. And according to our inequality symbol, it is less than or equal to. So x is less than or equal to 8. Again, we're not just solving them, we're also graphing our inequality symbols. So here's our number line. According to the number line, 0, of course, separates them. I'm not going to write numbers 1 through 8 because you should understand that positive numbers are on the right by now. So I'm just going to write 2 for the 6, and then, of course, an 8 on the right-hand side. And on the left, I'll do -2, -4. You kind of get the picture of what's going to happen there. Okay, according to this, it says x is less than or equal to 8. So what that means is this x can be any value that is less than 8, including 8 as well. So if we're going to include 8 in our solution, this time we're going to have a shaded circle. And what a shaded circle means is that 8 can be included in our answer, in our solution set. And it says any values that are less than, well, all the values that are less than 8 are going to move to the left, so we shade our graph to the left. And of course, we put the arrow on the end of our line to mean that the line, of course, never stops because numbers are infinite. What if we have one more problem? Let's say if we have a -2x is less than 4. -2x is less than 4. Again, we want to solve the problem, and we know what to do. Split it down to equal sign. All we have here is multiplication, so the opposite of multiplying is to divide. So we're going to divide both sides by -2. Whenever we multiply or divide our inequality by a negative number, it's going to affect our inequality sign. So let's go ahead and finish off the problem. 2's cancel. We have x left on this side. 4 divided by -2 gives us a -2. Well, again, because we divided by a negative number, and again, the rule is if I multiply or divide by a negative number, my inequality symbol has to change directions. So instead of being x is less than, it becomes x is greater than -2. X is greater than -2. I'm not going to graph this one, but let's just say we know that the graph or that this statement means that any value that is greater than -2 would be a solution, but -2 is not included in the solution. So if we were to graph it, but I'm not going to graph it now, we would have an open circle on -2, and we would shade all our values to the right if we were to graph that on a number line. Okay, so we've done the graphing. We've looked at some inequalities in terms of being able to graph them and being able to solve them. Last thing we want to do is look at an inequality word problem. Let me see. Oh, I am so sorry. I thought I had one, but I don't. So I guess we're going to stop right here. If I find the inequality word problems, we will carry on from there.